Today we'll discuss one more topic. It's called onload tap changes. We are not going to discuss the mechanism inside the VLTC. We'll understand what is this diagram is. In every transformer nameplate details you will find a small diagram like this. So what is the purpose of this diagram? We have to understand. So we consider a case of a 50 MVA transformer. Here that primary voltage is 230 kV, secondary voltage is 11 kV, and primary current is 125.51 amps, secondary current is 2624.32 amps. Here the tap positions are from 1 to 17, and this 230 kV is the nominal tap. This is 9A, 9B and 9C. And the highest voltage is 253 kV and the lowest voltage is 207 kV. And this is the secondary voltage 11 kV we have to maintain. So when the primary voltage rising, we are reducing the tap to maintain the secondary voltage 11 kV. Whenever the primary voltage is reducing, then we are increasing the tap from 9 to 10, 11, 12, 13, 15, 17, so that the secondary voltage maintain constant. So actually we'll zoom out in one more picture and we'll see the diagram. This is the main winding and this is called as tap winding. So main winding is made of solid core conductor, whereas the tap winding is made of multi-stranded wire. And this is actually 100%. And this is the additional winding. This is 10%. When this 10% winding is added, so we take the case of a tap position 9, this is 100%. When the tap position actually we are reducing to 1, in that case this 100 plus 10% will be added, so this will be 110%. When we are increasing the tap to last one is 17, here the 10% will be step by step we are reducing. So this 10% winding produces the flux which is oppose the main flux. This is 100%, this is 10%, resultant will be 90%. So this is the principle utilized in case of VLTC additional winding arrangements. Now the basic formula is like B2 by B1 is equal to N2 by N1 equal to I1 by I2 is equal to K. This is called as transformation ratio. Now we'll take the case B2 by B1, primary voltage and secondary voltage equal to N2 by N1. So this is constant, so we are not changing anything in the secondary windings. So the final formula will be B2 is equal to B1 by N1. When the primary voltage increasing, number of turns we have to increase so that the secondary voltage maintain constant. When primary voltage decreasing, the number of turns we have to decrease so that the secondary voltage remain constant. So this is the basic formula utilized for this voltage. So additionally, actually we are not adding any windings to the externally, we are not adding any winding, only that connection is changing here. This 3 to 4 and 3 to 12 is the changing point where the winding connection will be reversed. Here you can see one tapping chart here. Here actually this is total tap position is 1 to 17. Here this is the nominal tap 9A, 9B, 9C. And here onwards this is 100% winding is utilized. Now when 10% is added, so this will be 110%. When this 10% is connection will be in a such a way that it will oppose the 100% winding, then it will be 90%. This will be in tap number 17. So this is the nominal voltage. And here step by step actually we are adding. That means when the primary voltage is rising, we are adding step by step, plus this is 100%, 1.25%, 1 plus 1.25%, plus 1.25%, like that we are adding. So like that same way, minus 1.25%, minus 1.25%, like that the final will be 110%. Here it will be 90%. So this 90% into nominal tap 230 kV is equal to 207 kV. This is in tap number 17. So 100 similar way, 110% into 230 kV is equal to 253 kV. So this is the calculation actually. So to understand this thing, we take one polarity wise connections. This is called additive polarity. We'll take a small transformer. Primary voltage is 100 volt. Secondary having two tappings. One is 6 volt, one is 4 volt. So the resultant will be 10 volt. This 6 will be adding to the 4 volt. This is called as additive polarity. But in case of, I will change the slightly connection only. This is called as subtractive polarity. Here the same transformer, I will just alter the connection. Now here it is same 6 volt tapping, here it is 4 volt tapping. Now resultant will be 6 minus 4 is equal to 2 volt. So resultant is now changing. So this is the principle utilized in case of additional windings for the voltage. So when we are adding the additional winding, or we are placing the additional winding in such a way that whatever the flux produced by the main winding, the additional winding flux will add to the main flux. When we are doing a connection in such a way that whatever the flux or the produced by the tapping winding, it will oppose the main flux or the main winding flux. The resultant will be that 2 volt. So this is the principle utilized in case of OLTC. So the tapping will be like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 and 17. So this is the nominal tap. Actually it will be 9A, 9B and 9C will be there. When we are doing that motorized operations, the tap will not stop here in the 9A or 9C. It will stop in the 9B. So actually this additional winding 10% actually divided into 8 parts. So 10 by 8. So this is each part made of 1.25%. So here to here is 1 point plus 1.25%. So here it is 100%. And like that here it is 1 minus 1.25%. Now here in the tap lowering case, so when primary voltage is rising, we are reducing the tap. So here number of turns also we have to increase. So here 1.25% is each step, it will add 1.25%. Like it is 100% means it will be 101.25%. Next step will be 102.5% and so on. It will go to 110%. Similar way, now in case of when tap we are rising, minus 1.25% will be there. So it will be 98.75%. Next will be 97.5%. Like that, finally it will come 90%. So this is the actually principle utilized in the OLTC. Now we'll consider the case of a tap number 8 and tap number 1. I have considered only one phase only, but internally 3 phase means 3 phase will be connected. So here tap number 8 means here it is the main winding, and this is only adding 1% only. This is plus 1.25%. So here it will produce a flux in this direction. You can see. Like this. So when this pre-selector switch connected 3 to 4, that means we are reducing the tap and we are adding that additional winding. So the voltage will be 232.875 kV as per the chart. Same way, this is the main flux. Now when the tap is number 1, that means 110%. That means this is 100%, and this entire 10% of the winding it will be added. So here you can see now the entire 10% is, this is adding to this 10%. So resultant will be 110%. In between 8, then actually 7, 6, 5, 4, 3 will come. So each step 1.25% will be added. So this is tap number 8 and tap number 1. Here this pre-selector switch is important. Here the changeover of this connection will happen from 9 to 1 or 9 to 17. So 3 to 4 connected pre-selector switch means it is going to reduce the number of tap from 9 to 1. when 3 is connected to 12, on the next picture I will see pre-selector switch connected to 3 to 12. This is actually tap wear increase. This means that the additional winding we are connecting in such a way that it will oppose the main flux. So the next picture we will see. This is tap number 10 and tap number 17. So 9 next coming to 10 and so on it will come to 17. When the primary voltage decreasing, so we are connecting the additional flux in such a way that it will oppose the main flux. So this is the main flux direction. Now this is connected to 3 to 12, you can see. So it is one step. This is 1.25%. So now the flux will be like this. You can see this is opposing. This is direction is downside. This flux will produce in the opposite direction. So the resultant will be 98.75%. So like that, same way, this is the main flux, and here you can see here it is completely this 10% is opposing this 90%. So this is 100% and this 10% is opposing. This is minus. So resultant will be 90%. So in step number 17, it will be 90%. And each step will be 1.25%. So this is the step number 17. So like that, this is the tapping chart. Here to here, this is the secondary voltage. You have to maintain 11 kV. When this is nominal tap, when primary voltage increasing, tap we are reducing. When the primary voltage is decreasing, we are increasing the tap to maintain the secondary voltage constant. Hope you have understand those actually internal arrangements. So this is for entire 3 phase. So whatever diagram I have shown you for one phase only, here it is U, V and W 3 phase connection is there like this. So this is the additional winding connection actually. So the pre-selector switch 3 to 4 and 3 to 12. This is for actually subtractive connection. This is additive connection. Hope you understand this internal connection diagram. In RTCC panel, we'll find 3-4 important annunciation. One is the OLTC upper limit reached, one is the OLTC lower limit reached, one is the tap changer out of step, and one more is the tap changer stock up. This suppose our tap position are from 1 to 17. So whenever we reach 16 position, it will give an alarm and it will alert the operator that we are reaching the highest tap positions. Similar way, suppose our tap position is 2 and it will give an alarm that we are reaching the lower limit. Next tap position is our lowest tap. So these two are upper and lower limit reached annunciations. One more is the tap changer out of step. So you will find one switch in the RTCC panel. It is called master follower switch. Suppose 2 transformers running in parallel. We are keeping one transformer as a master and one transformer as a follower. So whenever we are doing tape changing in the master transformers, automatically the follower transformer follow the same sequence. Suppose due to some reason, technical reasons or some control circuit reasons, suppose due to some reasons follower transformer sequence not following, automatically this tape changer out of step will come. Suppose master's transformer we change from 9 to 10 tape position, the follower transformer follow the same sequence from 9 to 10. Due to some reason, if it is not happening, automatically this tape changer out of step will come. The last one is the tape changer stock up. So the transformer tape position should complete by 33 revolution, nearly 6 seconds. If it is the tape position changing is not completed within the specific time and the specific revolutions, automatically this tape changer stock up will come. This will indicate that internal some mechanism issue is there.